Every single project in Unreal is plagued by this setting being turned on by default. Today we create a tool to easily get rid of it. And alongside that, we'll discover how a simple tool that literally takes 5 minutes to make can take weeks for someone that works in a big AAA studio. And for that reason, I've packed it up for you to download, so you don't have to break a sweat for it. Just follow the link in the description. But why should we ensure that we're not generating LightMapUVs in the first place? Well, unless you're working on a project that's using static, baked lighting and you keep them around, you're essentially wasting memory. The LightMapUVs, without going into much detail, are usually generated by grabbing the UV channel 0 and rearranging it in a different layout, which is then saved to a new UV channel that your static mesh wouldn't otherwise have. So that's extra data you carry around for absolutely no reason, which can get quite cumbersome, especially with high density geometry and, when you're using Nanite, especially with poorly compressible assets, like vegetation. Alright, if you weren't already aware of it, let me introduce you to the amazing world of editor utilities. They're what allowed me to massively, single-handedly modify the giant Valley of the Ancient project in a human time frame to render the whole environment in one single draw call. There are two kinds of them, the ones that operate on the content assets and the ones that operate on the actors in the scene. We need the first one this time, as we'll use it to automatically uncheck the Generate LightMapUVs option and rebuild every static mesh asset. Wait, isn't this sort of things exactly the reason why the Edit selection in Property Matrix exists? Yes, it is. But if you ever tried to edit more than a handful of assets through it, you already know that's a guaranteed engine crash. Plus, through the editor utilities, we can do so much more than changing few checkboxes around, but I'm getting ahead of myself here. Let's start from the basics. First thing you generally want to do in an asset action utility is to get all the selected assets. In our case, we also know we're gonna work only on static meshes, so we can use the node version that pre-filters the selection with a class. We then create a for loop to iterate through these assets one by one. Weirdly enough, they're still given to us as a generic object type, so we have to cast them as static meshes. I'm used to then immediately save every object of an iteration process to a local variable named current whatever to make the graph easier on the eyes and brain by avoiding zipping kilometric lines. Now we want to set the current static mesh generate LightMapUVs parameter to false. There's no node around to do such thing by default. We have to first grab the static mesh editor subsystem, under which we have the perfect node for the task, set LOD build settings. If your mesh is Nanite enabled, it is still counted as LOD 0, even if technically it doesn't have any LODs. Now we have a problem though. We only need to change one member of this struct, but we're still passing through the whole thing. How can we be sure to not be changing anything else? Well, let's first get these settings from the mesh to then just override the bit we care about in this case. Cool, now the tool can potentially be run on all the content by selecting all static meshes, right-clicking and going to the scripted asset actions. Yeah, let's not do that. That would be a guaranteed engine crash. We still have a few things to take care of. First, let's shield ourselves from an halfway through the process crash by saving each asset right after it has been modified, which is also cool because it saves us the hassle of hitting Ctrl+Shift+S on the keyboard after the tool runs successfully. Nobody's got time for that. Secondly, the thing that usually crashes the engine in this and the property matrix case is the PC completely running out of memory, because each asset has to be loaded in before being processed, but there's nothing telling the engine when it can unload stuff. So let's try to avoid that by explicitly telling the engine to unload the mesh after it's done with it. You know what? Even better. We first check if the mesh needs to be modified, so that if it already doesn't have LightMapUVs, we unload it straight away and avoid rebuilding it. You'll see quite soon that taking care of these little nuances is quite important with nowadays giant assets, as this kind of operations can take quite a long while. One last fun quality of life bit we can add is a little prompt at the very end of the cycle that celebrates the engine successfully not crashing. Not required, but nice to have. And that's the core of it. You can pretty much keep every content in check with this little script. And if you can't be bothered making it for yourself, you can just download it for free by following the link in the description. Now, before moving on, I want to spend few quick words on utilities housekeeping. By default, every function you'll add to any action utility will show up in the scripts list, in one unique long list. Imagine what happens if you have loads of them. But if you have, let's say, a collection of scripts that are only operating on static meshes, like this one, you can tell it to the engine by adding such class to the list of supported ones, so that the script will only show up if there's at least one asset of that specific kind selected. One more thing, you can nest your scripts under parent categories by assigning one to the script function itself. Sadly, it doesn't support further nesting like the blueprint itself. And in case you don't want a function to show up at all in the list of scripts, because it's just one you need to keep your scripts tidy, from the same menu you can uncheck the call in editor property. Alright, let's start to take things further. At the moment, if you want to go through the whole content, you have to select the content folder, activate the static mesh filter, select all, and then run the tool. That's such a time sink. What if we could just click on any random asset and send the tool around the content by itself to find all the static meshes for us? That would be pretty neat. Let me introduce you to the asset registry, the thing that allows you to do exactly that, in a totally unintuitive and undocumented way, like 99% of the very useful things you can do with editor utilities. Let's call the getAssetsByClass function, and let's tell it we want only static meshes by creating this top-level asset path structure with the getClassPathName node. Now, this will return a list of all the static meshes in the whole engine, including the ones inside folders that are normally invisible to you and that can't be locally edited. So we need to filter them out with the runAssetThroughFilter node. Let's add only the main content folder, which, whenever you're dealing with actual paths, it's called game, and let's check the recursive paths bool, so it will keep all the files in its subfolders too. Now we run another for loop, in which we first get the asset from the asset data structure, to then proceed in the very same way as we did before. Okay, but I'd still like to have the flexibility to decide if I want to run the tool on the whole content or just on a bunch of selected assets. Should I create two separate, nearly identical functions? Nah, we just need to add an input variable to the function and branch based on its value. Having done that, when we'll try to run the tool, the engine will prompt us to set the value of set variable, allowing us to decide what to do. Alright, let's say we're not sure about what we're doing. So we want to run our tool, but have the ability to eventually revert the changes made with our trusty Ctrl-Z. In the specific case of this tool, it shouldn't be needed, but you never know. So maybe let's add it as an option. The Ctrl-Z thing is technically called transaction, and it works in a pretty straightforward way. Whenever you want to make something revertible, you tell the engine at the very beginning of your script that you're beginning a transaction, which you can describe in a meaningful way. That will assign your transaction an index, with which you mostly got nothing to do with, unless you want to double check that the engine succeeded in creating it, in which case it will have a value of -1. Let's say we don't want to proceed if we can't Ctrl-Z, so we issue an error prompt and end the tool here. Cool, once the transaction has been opened, you must remember to close it. So at the very end of our script, if the transaction has been enabled, we tell the engine to end it. But you also need to tell the engine what to store into your transaction. So, if we enable Ctrl+Z, we call transact object for the object we are about to modify, right before we actually modify it. This way we save its state at that specific point in time, which will be the one to which the asset will be reverted to once we eventually hit Ctrl+C. That's basically it, aside from few quirks to be aware of. To keep an object into a transaction, we can't unload it. So, in case we end up modifying it, we need to skip the unloading part if we're making the transaction, which reopens the full memory-related crash question. My take on it is that if we're running the tool on the whole content, we surely don't want to open a transaction, so we'll force the Ctrl+Z to be disabled. Since you can't edit input variables, we can create a local one that will be set up at the very beginning of the script and will be used instead of the input one. Alright, now we really start to enter the realm of the tool development for bigger teams. One where you want to better keep track of what has been changed, aka you don't want to trust people to be able to do their job. I mean, you maybe want to make these sort of things for yourself too, if you're running more complex tasks with your tools. But I'd say that if you're in a team, these things we're about to implement should be added by default. So, as said, let's say we want a permanent way of keeping track of which were the meshes that have already been assessed by the tool, with information about which of them were already good, which have been modified, and which haven't because of an error of some sort. By permanent, I mean something that is not just printing to the log, as it can easily be lost. A nice way to do it is by creating and assigning tags to the assets, which is a feature the engine has that is well hidden under a misleading nomenclature. I'm talking about collections, which is this little tab stuck in the corner right here. Here you can create and parent collections to which you can assign any asset you have in the content. The fact that these collections are actually misnamed tags is also confirmed by the fact that to access their editor utility functionalities, you have to go through the asset tags subsystem. So let's see how we can leverage them to keep track of what happened during the script execution, plus as a further insurance against eventual crashes midway. Let's add the tag thing as another option alongside one more to specify if we want to run the tool while keeping any tag that might already be assigned or start from scratch. And let's position ourselves before we begin the transaction. Here we'll add a good chunk of code to set everything up and eventually stop the execution if anything goes wrong. In the unlucky case the engine crashes midway, the tags assigned up to that point should persist. So, by telling the tool to not reset them, we'll be able to skip all the assets that have already been processed previously. Okay, it sounds like a plan. Let's set everything up. Let's create a boolean that will default to true, which will allow the tool to proceed only if everything with the initial tag setup went smoothly. If we're tagging, let's set up a list containing all the tags we want, and let's put the parent one first. Then, let's iterate through them and save the current tag and index to local variables. Before jumping into the iteration code, let's add the check for the correct setup of the collections. If the value of the variable is still true, we connect to the rest of the code we already wrote so far, otherwise we issue an error prompt. Since the error will be able to come from many different places, let's set up an empty text variable for the body of the prompt, which will fill up dynamically. Alright, back to the iteration body. We first check if the current collection already exists. If it doesn't, we create it. If anything goes wrong, we set the boolean to false and we append to the error message something that will allow us to understand where things went wrong. We want to append things instead of just setting the error message so that if there are multiple points of failure, we get notified about all of them. In case the collection is created successfully, we proceed towards another if statement. I'll carry on later with it though, let's first take care of all the other cases up to that point. If the collection already exists, we must check if the user told the tool to reset them. If they didn't, let's just proceed to the if statement we added at the end of the other case. If we have to reset the tag, let's empty the collection. Again, if anything goes wrong with that, we set to false the bool and we append an error about it. Otherwise, we proceed to the if statement. So, what's this about? Let's use it to check if we are not currently evaluating the first tag, which is the parent one. If that's the case, we want to reparent the current collection to that. One more time, if anything goes wrong, we set the bool to false and add an error about it. This part is done. Now we should have all our collections correctly set up. Let's move forward with the code and position ourselves right after we get the current static mesh. If we are tagging, here we want to check if the current asset is already tagged by the tool at all, because we want to skip it in that case. To do that, we need to tell the asset tag subsystem to give us all the collections that contain this asset, which is done through the asset path name. So let's get it and also save it to a current variable. Maybe it will be handy again later. Once we have the list of collections, let's check if the parent one is among them. If so, we end the code here. Otherwise, we add the current asset to the parent collection and we proceed with the rest of the code. Next place to edit is the case where we checked the mesh and saw that it's already good. If we're tagging before loading the asset, we check if it isn't already in the good assets collection, and if not, we add it there. Same sort of thing after we edit the mesh. Before saving it, we check and eventually tag it as modified. Last one is to tag as error if the save command doesn't succeed. That should be it. Notice that we're not prompting anything anymore, since constantly interrupting the iteration would be incredibly inefficient. If you need, I think in this case it's just better to log anything you want to communicate. Actually, one last small bit. If we are running the tool on the whole content, we can check if the asset is already tagged without first loading it, which is a huge time saver. For that, we can add a quite similar copy of the code we already wrote before, where we get the current asset from the current asset data, and we swap the get path name from loaded asset with an handmade string that should always match it. As far as I'm aware, the asset path name should always have this composition, but in the unfortunate case it doesn't, we still have the next check on the loaded asset as backup. The tool has already got quite bigger than expected, hasn't it? Well, time to meet the final boss, source control. A necessary evil which is the bane of every AAA studio employee, an unescapable annoyance that can only be enjoyed by weirdos such as programmers and engineers. Editor utilities can make our life easier on that front, which honestly is amazing. Let's add this final feature. Just a quick introduction for whoever might not be aware of what source control is. It is a way to connect your project to a server and make sure that you're always working on up-to-date files, or at least to know what's outdated on your side. When you're done with your job, it's an easy way to send your stuff to the server so that your changes can be propagated to the rest of the team. And, very important, it's also a way to make sure nobody's editing the same file at the same time. It also enables you to know the entire history of each file, who made it and who edited it, which gives you access to everyone's favorite skill in team working, blaming others. The real downside are the layers of bureaucracy that inevitably arise in each studio in the attempt of keeping everything tidy through commit rules, tags, time windows, etc. Anyways, let's go back to the beginning of the script and let's start. Right after the first check for transactions, let's make sure that source control is enabled and available. If it's not enabled, we just want to carry on. If you're using this tool as a solo developer, you're likely not using source control at all, but you still want to be able to run the tool, I guess. But if it is enabled but not available, maybe because the server has some issues, we want to prompt an error and stop the execution, as doing stuff offline in a source controlled project is very unadvisable. If everything is good, let's save the value to a boolean variable so that we'll be able to just use that later down the line to branch around. Now that we're accounting for source control, we need to be mindful about an aspect of collections we previously skipped altogether: the type of collection we're going to create. Thing is, they can be local only if there's no source control, otherwise they have to be either shared or private. The first one means that the collection with all the assets assigned to them will be visible to everyone. The other will just be visible to you, like the local, but still versioned by the server. So, as we said, if there's no source control, we force the collections to be local, otherwise we let the user decide by adding another input variable. But since there might be a mistake and the variable could still be set to local anyways, let's ensure that in that case we force it to be private, which is the closest thing in terms of behavior. Now we move way further into the code, right after we check if the current asset is already tagged and should be skipped. In case we have to proceed with the script and source control is on, we want to make sure to be allowed to work on the asset, that we're working on the up-to-date version of it, and that we're allowed to eventually edit it. So let's grab and save the current object path string, as every source control related node wants that as input, and let's query the file state. Let's save it to a variable and let's run a preliminary check to see if we should work at all on that file. We want to proceed with the current asset if it is valid and it is source controlled and it is not marked for delete and it is not ignored by the source control and it is not currently being worked on by someone else. If any of these conditions fail, we skip the asset, we give it the error tag and we unload it. Otherwise, we check if it is up to date. If it is, cool, we carry on with the rest of the script. If it is not, we have a few more checks to run. If the tile is modified, meaning that your version is different than the one on the server, but it can be reverted, meaning the source control can just throw away your edits and go back to the official version, and let's add this to the inputs, the user said it's fine to eventually revert modified files, then we can proceed to revert and sync the file to bring it up to date and then proceed. If the check fails, we can try to directly sync the file, because maybe it has just been updated on the server and you still don't have the last version. In case any of these operations fail, we just slap the arrow tag on, unload and skip the asset. Alright, next step is to check out the file before editing it. If we're using source control, we first check if we can check out and edit the current asset. If not, error, unload and skip as usual. Otherwise, we can check out the file, meaning that we tell the server that we're editing this file and we'll stop everyone else from doing it until we keep that state active. If we fail to check out the file for some reason, the usual fate awaits it. Otherwise, we can finally proceed with our script. Then, right after successfully saving the modified asset, if we are source controlling, we add its path to a list of all the modified objects, which we create now. That will be essential for the very last operation we need to write down. At the very end of the script, right before cheering up for everything going well, we have one more thing to do: send our changes to the server. If we're using source control and if the user wants to do it automatically, of course, let's check in the list of modified files, passing as description an user-defined string. If we don't succeed, we issue an error prompt. Otherwise, we can finally celebrate. So, that's how a simple tool can quickly escalate in complexity depending on the environment you work in. You'll find all these versions to download by following the link in the description. So, what do you think? Did you get any cool ideas for automating very annoying tasks, or just increase the quality of your content through useful tools such as this? Let me know in the comments. If you want to absorb more useful knowledge about game development, you might be interested in joining my Discord server and signing up to my Patreon, where you'll find more useful videos and be able to participate at live courses that I'm gonna hold every now and then. Other than that, you can just subscribe to this channel to be sure to not miss anything. I'll catch you next time.